Alright, on this, we're going to actually get essentially our third and final trig definition. And this will give us a very, very handy tool to solve lots of problems. So this will be well worth developing this whole concept here. But first off, I want to review, because it'll tie all this together, the first couple of trig definitions we had. So we're going to review these first two because this will kind of pull all this together into this third definition. And we continue to use these two as well. The first one was our coordinate plane definition. Okay, so if we remember this definition, we have, of course, the coordinate plane, and we had to have our angle in standard position. So if this is my angle, and we defined this angle by theta, what did we have to have on the terminal side for this one to work? What do we need on our terminal side for this to work? We needed a point. No, we needed a point. For our first trig definition, we had a point, right? And we called this point xy. So the angle's in standard position. We have point xy. And what else do I have to have on this? The distance from here to here was what?
The ray R.
We'll call that R, right?
I was trying to think of like a word for it.
Yeah, right. And so all of our trig definitions were based on these things. We said, that the cosine was what? Cosine theta is? Cosine theta is what?
That's the x over.
X over R. We said that the sine of theta is y over r, and that the tangent was y over x. Right. So that is based on the coordinate plane definition. I'm not going to go to the other ones. We don't need to do that. And then, right, we moved on to chapter 2. We had based on right triangles, which was kind of the trig you had done in geometry and algebra 2. So we have our right triangle definition. And so this one, of course, was not based on the coordinate plane now. Right now we had just a freestanding right triangle. And this time the theta is just one of the angles. And we also identified the different sides based on that angle. We called the side opposite the opposite side. So we had the adjacent side and we had the hypotenuse. All based on a freestanding right triangle. And so now we said, then if we say the cosine of theta now is what ratio? Adjacent or hypotenuse. And that the sine of theta, opposite of the hypotenuse, and the tangent of theta is the opposite over the adjacent. We've done that, and that's what we've done so far. Alright, so now we're going to get one more definition of these trig functions. And it's called the circular definition. So part 2. Alright, so this definition is based on what's called the unit circle. Okay, so I guess first off, let's define the unit circle. So, like it sounds, I guess first off, the unit circle is it's drawn on the coordinate plane. So now we're back to the coordinate plane again, right? So we had the coordinate plane, then the freestanding triangle. Now we're back to this coordinate plane again. Its center is at the origin of this. This is we're talking about the unit circle now.
Can you move it up?
Yes, I can. You're welcome. So center is at the origin. And it has a radius of 1 unit. Okay, so let me show you how this is going to work. First off, I got it straight. So if we look at this, draw this with me, but we have a coordinate plane now. I only have one. You can get a ruler if you want. So we have a coordinate plane. I don't know if I have a compass though.
That does look really good. I'm impressed.
I don't know if I can.
Oh, we did.
See if I can make a decent. Well, this one. This one keeps moving on me. Alright, that's not too bad, but not too good either. Alright, that's not too bad. Alright, so
We have to draw that circle.
yeah, you need, so it's based on a unit circle. So here's the center. Okay, now let's draw an angle in standard position. So we're going to have the angle in standard position. So that means I'm going to have I've got, here's the initial side, and then I'm going to put a terminal side here. So we're going to call this angle here theta. Alright, yes. Now, here's what makes this a little unique, because this is called a unit circle, so the radius is 1 unit. Okay? So the distance from here to here is how much? This is 1. So it's 1 from here to here. Now, if we think of it this way, what we're going to do is, if we kind of look back, we're going to call this point xy. right? Now, if we base this just on our our first definition, right, of the coordinate plane, what would be the sine of theta equal to? Sines, which one? Okay, sines y over r, but what is r in this case? That's a 1, right? So this is a unit circle. The radius is 1 unit. That means that the sine is y over 1, which means that the sine is just y. The cosine of theta is going to be x over 1, which means that it is just...
Wait, so we're like the circle and the terminal selecting together, like that point?
Yeah, that point there. That point here is xy. And then the tangent of theta is going to be y over x. Okay. Now, another thing to look at on this is we actually can somewhat use our other definition. If I take and extend this line down and make a right triangle, if I look at this right triangle, this distance from here to here is what? If this point is xy, this is x, right? I went over x, I go up y. So, the cosine of this angle, let's do cosine first. The sine of the angle would be what? Y, what? Let's do cosine. Cosine theta is going to be x over 1, which would be x. The sine would be y over 1, which would be y. Now, using this definition, if I know any point on the circle, the angle that makes is just the sine is always the y coordinate, the cosine is always the x coordinate. So it gives a very, very convenient way to read off these values, especially of the ones that have exact values. Okay, everybody with me? I want to look at the first quadrant and kind of the important points on the first quadrant of our circle. So this is the important points. So what I'm going to do is I'm just going to draw a large first quadrant only. So we'll say this is the first quadrant. Alright, so that's the first quadrant, right? So this is the outside of the unit circle in the first quadrant.
Hey Stu, I want to be here tomorrow.
Okay, I will try to... You will too?
Jeremy.
First point I want to talk about is this point right here. Now, what point is this right here?
That is x.
What point is that on the coordinate plane?
X, yeah, x0.
This distance is how far on the x?
X.
This is a unit circle, right? So this would be 1. It would be 1, 0. Now, I am at what angle is this?
90.
Now, right here would be at 0 degrees. Or 0 radians. Now, why this is so handy? Because this tells me that the cosine of 0 degrees is what? Cosine is 1. The sine of 0 degrees is 0, right? Remember how this works from our definition. The cosine is x. The sine is the y coordinate. So at this point, cosine is 1, sine is 0. Okay, let's pick another one that's very simple. We look at the one up here. Right, first off, what angle is this?
90.
So this is 90 degrees, which would be pi over 2 radians. It's 0, 1. So, The cosine of 90 degrees is 0. The sine of 90 degrees is 1. So obviously every point on here could be an angle, right? But there's only a few angles that we really want the exact values of, and let's talk about those first. So if I split this right in half, so I'm just going to draw a angle here, a line here. So if I look at this one here, best I can, right there. Alright, so first off, what angle is this? Alright, at this point, theta is 45 degrees, which is how many radians?
1/4.
Pi over 4. What is my coordinates here?
Half and half.
Well, actually, maybe the best way to look at this is, I guess, with a special triangle. So, if we, because if I draw this line down here, in that box back there by the box by Marissa's rulers, if I draw this line here, I get a special triangle, right? This would be a 45, 45, 90 triangle. And remember, this distance is x, this distance is y. So let's look at that triangle. Now this is 45 degrees. I know that this side here is t and root 2t. But look, what is my hypotenuse length actually? What's this length? 1. So if I want to make this hypotenuse 1, I need to divide this by what? By itself, right? If I divide everything by root 2 over t, I'm going to divide every single angle by root 2 over t. That means that the hypotenuse is 1. And my x coordinate is 1 over 2. And the y coordinate is. So look what I did again. I divided everything by root 2 over t, root 2t, so I get this to be 1.
Why do you need it to be 1?
Because the unit circle has a radius of 1. So the distance from here to here is 1. So that means that this is coordinates of 1 over root 2, 1 over root 2. So, what's the cosine of 45 degrees? 1 over 2. What's the sine of 45 degrees? 1 over 2. Alright, so that's one of the key angles, right? Because I have exact values for that. Now, I'm not going to include 40 degrees because I don't have exact values for 40 degrees. What do I have exact values for, though? 30. For 30. Let's do 30. I have exact values for this one, which is 30. So, we're going to call this point theta is 30 degrees, which is pi over 6, right? And you will have all these memorized here shortly if you don't. Now, again, if I draw this line down like this, I get my special triangle. So let's look at that special triangle. So if this is 30 degrees, right? This is t, root 3t, and 2t. But yeah, I need this to be 1, right? The hypotenuse to be 1. So I'm going to divide everything by 2t. Yeah. So that means that my hypotenuse is 1. What's the x coordinate going to be?
Root 3 over 2.
Yeah, the t's cancel out. So the x coordinate here is root 3 over 2. What's the y coordinate? At half. So now we know that the cosine of pi over 6 or 30 degrees is root 3 over 2. The sine is a half. What's the other one I'm interested in on this one?
What?
What's the other angle I care about on this that has exact values? It would be the 60, right? So someplace up in here.
This is complicated. I know.
All right, so
Oh, I didn't go through this one.
what angle is that?
60 degrees.
60 degrees. How many radians? Pi over 3. Now, since, one way to think about this, since these are co-functions with the 30, what happens to my coordinates?
It flips.
They flip, exactly. So what's my coordinates here?
Cosine equals 1/2.
It would be a half, and the y would be
Root 3 over 2.
root 3 over 2. Very good.
I had a cram for computers.
Okay, y is 30 degrees. Y is it root 3 over 2 for the x.
Because I think about my special triangle here, right?
Wow, yours is.
Here's my 30 degrees. The x is
Yeah, 30 degrees.
the x is this distance, right?
Yeah, the cosine.
Okay.
And it's 1/2 is what?
All right. So to start going around,
This looks disastrous.
here's how I want you to do. Let's start with this. It's not as bad as it looks. All right. We know that I want to put the angles first. Angles, radians, and points in the line. So the angle would be 0 degrees, which is 0 radians. And what's the point?
1 0.
1 0. Good.
Let's do 90 degrees.
Now let's just work our way up.
Oh.
30 degrees.
This is 30 degrees, which is how many radians? Pi over 6.
Didn't you just give us this before we wrote this in our notes?
And what is this point?
That is
Root 3 over 2.
2 1/2.
Can we use this on a test?
Please.
Why?
You will memorize this for tests. In fact, sometime this week we will have a quiz, a memorization quiz of this.
This
You don't say that.
These told this week.
Okay, this next angle is what?
45.
Fire 4.
45.
Yeah.
Yes, it's actually quite, once you get the pattern down, you just go one way. So this is 45 degrees,
Pi over 4.
pi over 4.
Which is
And what's-
2 twice.
You're going to find out that all the 45s have the same coordinates, just positive or negative, plus everything else is the same as positive or negatives. This one here is how much?
60.
60 degrees,
Pi over 3.
which is pi over, coordinates are
1/2. That's right.
finally, this is 9 degrees, which is coordinates are